Today we're going to talk about acid-bases concept. Here we want to review something we learned in Gen Chemistry, and is Bronsted and Lowry concepts of acid and bases. So what we learned before is essentially that acid, and I'm going to write a general acid, right? Say that we have this acid HA in water, and this is my arrow for reaction. And here, what happens in water, we find these two species. So what we see here is that this molecule, which we're going to call the acid, has donated a proton to the water. In this, we're going to call the base. So right here, the concept of Bronsted Lowry says that acids are proton donors and the bases are proton acceptors. So that's one concept of Bronsted Lowry. Another thing that is important is the concept of conjugate pairs. Notice that when I did this reaction with a generic acid and I had the acid and the base, we formed this species. Here we're going to call this species the conjugate base. And this species we're going to call, oh, I'm missing a formal charge. Here we go. So this species is called the conjugate acid. So that is general thing in Bronsted Lowry. And but now we're adding, now that we are into organic chemistry, we're going to add one more thing to that concept. Here we're going to say also that bases, notice that we have this pair of electrons in the oxygen. Here also we know that in an acid, say that this example was hydrochloric acid. Well, this bond is polarized. And it is polarized. We're going to write the dipole this way. That means that the proton, this end of the dipole is delta positive. This end is delta negative. Well, that means that here we have an electron deficient, say this place in the molecule is electron deficient. And here we have a place with high in electron density. Well, we're going to say that this is electron rich. So I'm going to draw this little arrow because we have that. This is electron rich. And if you remember what we studied when we learned resonance, we were moving electrons. So arrows in resonance, we use these arrows to illustrate the flow of electrons. And this is what we're doing here. So we didn't say anything. We just said at the beginning, the Bronsted Lowry concept is acids are proton donors. This acid had given this base a proton, and this is why this, by donating a proton, this became a negative, the conjugate base, and this became hydronium, if you guys remember that name, which is a conjugate acid. But how that happened? Now we're going to do that showing the flow of electrons. So this species, being electron rich, is going to attack on the electron poor species. Remember that this we said was the delta positive end, this was the delta negative end. So electrons flow, electron-rich species attacking on something that is electron deficient. Then this bond is going to break, and we're going to assign the electrons to the this part of the molecule, A, that's a generic acid, and that's how we form that. So this, again, always remember we show flow of electrons. So from an electron-rich place, so let's say from something that is delta negative or formal negative, full charge or partial. Or here we can have lone pairs by electrons. For example, is going from an electron-rich place to an electron-deficient place, which is delta positive. So we're going to talk more about that in the next video and about reactions and equilibrium.